Hey guys! In today's video, we're going to be going over CS50 Problem Set 2 Caesar. So make sure to subscribe to the channel if you haven't already, because I'm going to be posting CS50 solutions every single week. Let's jump straight into Caesar now. Okay, so the point of Caesar is actually to encrypt some text based on the user's key. What does that mean? So let's say a user runs the program, right? The program's called Caesar with /Caesar1. That means the user has chosen the key to be 1. So what does that mean? So if the user types the letter A, our program would need to print out the letter B. So depending on the key, so the key is 1, so A prints out B because we need to convert A to B. We need to skip one step based on the key, okay? So similarly, B is converted to C and C is converted to D, right? It just moves one step based on the key. So let's say the user types /Caesar2. So now the key is 2. So if the user types in the letter A, we need to print out the letter C, right? In other words, A is the plain text, what the user types in, and C is the ciphertext, or what our program prints out. Okay, and so on and so forth. The key can be any number, right? This is just examples. So our program needs to prompt the user for plain text, right? They type whatever they want, and then we convert it to ciphertext based on the key, right? Okay. So let's just give an example here. Let's say user types in /Caesar1, and for the plain text they type in ABC. So our ciphertext, we need to print out BCD, okay? And notice here how it's case sensitive. So capital A turns into capital B, lowercase b turns into lowercase c, and uppercase C turns into uppercase D, okay? So the case still remains. And also, if you notice here, for the first time, we've not had this in previous problem sets, is that the key is not a normal input. So we don't use getString, okay? Rather, it's actually on the command line itself. So in previous problem sets, what we used to do is just run like /Scrabble, /readability, but over here, we run /Caesar1 or /Caesar, whatever the key is, right? So that's why we now have a command line argument. So rather than using int main void like we used to do in the previous problem sets, we now run this int main int argc string argv, because we now actually have to take an input on the command line rather than just leaving it void. Okay, so I hope that makes sense so far. And now there are two conditions for the command line argument, right? What are they? So first, what does argc mean? Argc is an int, and it's actually how many arguments there are, okay? So argc. So the first argument here is /Caesar, and the second argument in this example is 1, okay? So argc is equal to 2, okay? So the first condition is that argc always has to equal to 2. /Caesar is the first argc, and the second one is the number, right? The key. So for example, we can't have a /Caesar1 space 1, because that doesn't make sense, right? That we don't know what the key is. So that's why argc always has to equal to 2. And why can't, so in this case, argc is 3, right? /Caesar1, 1. So that doesn't make sense. And it can't be 1. Argc can't be 1 either, because then it would just be /Caesar. That's the first argument. So it always has to be argc is equal to 2. /Caesar and the key. 2 arguments. And the second condition is that argv1 must only contain digits, okay? So why is that? Let's take an example over here. argv0 is /Caesar, right? So that's fine. argv1 must only contain digits because let's say the user types in /Caesarx. Then we don't know what the key is, right? It doesn't make sense. Or let's say they type in /Caesar1x, right? That doesn't make sense either. So argv1 must contain only digits, okay? So those are the two conditions. And if it doesn't fulfill these conditions, both these conditions have to be fulfilled. Otherwise, we need to print usage /Caesar key, which basically is just telling the user how to use the program successfully, okay? How to use the program correctly. So let's try to put this, whatever we learned, into code. And it should be simple enough, right? So if we know the first one is argc needs to be 2. So if argc is not equal to 2, we need to print the error message and return 1, right? Quit the program. So if argc is not equal to 2, and how do we say that? We actually say that by using exclamation mark and equal to. So this just means if argc is not equal to 2, what should we do? we want to print the error message, which tells the user how to use the program, print usage./user key, and we also want to exit, right? We want to return 1. Okay. The second condition is argv1 must only contain digits. And over here, we actually need to use a loop. Why do we need to use a loop? Because we actually need to go through every single character of argv1 and determine whether or not it's a digit. Okay. So again, so let's say it was just ./1x. If we didn't use a loop, it would just check for the first character. Whereas we need to actually go through the entire argv1 and check one by one. Is this character a digit? Is this character a digit or not? Okay. So that's why we need to use a loop. So we need to use a for loop, right? And by this point, we know how to use for loops from all the previous problem sets. So let's say int I equal to 0. Let's set an index and set to 0. And I needs to keep on going as long as I is less than the length of argv1, right? So as long as I is less than strlen argv1, right? I++, which basically means go through the entire argv1 one at a time, starting from 0. And what do we need to check for? If it's a digit, then we need to print the same error message. But how do we actually check whether or not something is a digit? Well, it turns out there is a formula called there's a function called isDigit, right? And again, we wouldn't know this. This is not common knowledge. It's not common sense. You would know this because first of all, it's in the CS50 explanation, right? And also by just playing around with the CS50 manual, learning different functions, things like that. Okay, so we need to check if it's a digit, right? And this is under the header file called ctype.h. So let's include that. And also, if you remember from the previous problem sets, strlen is actually under the header file called string.h, right? So to use strlen, we need to use string.h as well. Okay, so we've used those header files. So if is a digit, right? So we need to check whether or not it's a digit according to this argv1. So if it's not a digit, then we want to return an error and quit. So again, if exclamation mark is digit, argv1 I, right? What do we need to do? We want to print again the exact same thing as we printed before. Users, we need to print the error message as well as return 1. Okay, so I hope that makes sense so far, right? We fulfilled the two conditions because as we said, argc needs to be equal to 2. So if it's not 2, then quit the program and print this error message. And argv1 needs to only have digits, right? So we loop through the entire argv1, one character at a time. And if it's not a digit, then print this error message and quit the program, right? So we've reached here so far. But now we know logically that the formula to convert plain text to ciphertext is actually plain text plus key. Plain text plus key will give you ciphertext, right? This just makes sense. So let's say plain text was A, well, what the user types in, let's say the user types in A, and a key of 1, we have to print out the ciphertext, which in this case would be B. Right, so that makes sense so far. But again, so we know the key needs to be an int, right? The key needs to be an integer so that we can make a formula out of it to later convert plain text into ciphertext. But if you notice here, argv, which is where the key is, argv1 is actually a string, right? So it's a digit, but it's considered a string. So let's say the key is 1. Well, it's still a digit number 1. But rather than counting it as an integer where we can do mathematical functions with it, it's counted as a string. Okay, so we need to convert the key into an integer so that we can do math with it, right? Okay, so in this example here, ./user1, 1 is a string. Okay, even though it's a digit, it's still a string. It doesn't count, the computer doesn't count it as an int because argv is a string. So we need to convert it to an integer, right? So let's see if there's a function to convert a string into an integer. And it turns out there is, and again, this is not common knowledge whatsoever, right? You need to know this by either reading CS50's explanation or by just going through the manual and figuring it out yourself. So it turns out that this function called a to I, which converts strings to an int, right? That's the definition here. And that's under the header file standard lib.h, okay? So I'm just gonna include that. Okay, so we know we need to have a key, right? We have a key, but now we need to convert that key into an integer. So let's just make an int, let's call it int k for key, right? Just to make it easier to remember. A to I, which is just convert string to integer, argv1, right? So we defined a variable called k, which is an integer, and now we assign the value of the key as an integer into k. Okay, so it's k for key, just to make it simple. And now what do we need to do? Well, now we need to actually prompt the user for some plain text. And how do we go about doing that? Very simple. It's been there since problem set 1, which is just using the getString function, right? So string plain text to get some string from the user. GetString, right? This is to get a string from the user. Let's say plain text. Okay. Okay, and now we want to print out the ciphertext. Okay. So getString plain text, and we want to print ciphertext. And then we actually need to use the formula and everything to get the actual ciphertext. So what we've done is prompted the user for plain text, and then print out ciphertext, and then print out the actual ciphertext. So print out the word ciphertext, colon, and then the actual ciphertext. Okay. So now, first things first, as we know from Scrabble and even readability, we know that different keys, according to ASCII, the lowercase and uppercase have different values, right? So if you remember, actually uppercase A has an ASCII value of 65, whereas lowercase a has an ASCII value of 97, right? So we know that over here, according to our program, it needs to be case sensitive, right? So we can already determine somehow that we need to treat uppercase letters and lowercase letters differently because they have different ASCII positions or ASCII values. So, okay, so we know that. So now what we need to do is we actually need to make a loop to go through the entire plain text, one character at a time, and convert it to ciphertext, right? So let's go ahead and just make the loop. And again, let's use a for loop. Again, we should be very familiar with for loops at this point. We should be comfortable manipulating them. So let's make another integer. Let's call it j, because we've already used I over here. So if j equal to 0, keep on going as long as j is less than the strlen of what this time? Strlen of the plain text and j++. Okay. So what this for loop means is just make a variable called j, index it to 0, keep on going as long as j is less than the plain text, as long as the less than the length of the string of the plain text, right? And j++, which just means go one at a time. Okay, so far this makes sense. And our first instinct here, right, and my first instinct here, so there's no shame in that, is printf. And what do we want to do? We just want to print the character. And what character do we want to print? We just want to print plain text, right? Plain text j plus k. And this is what makes logical sense for everyone, right? So the ciphertext, we want to print the ciphertext, right? So I placeholder C. So we want to print the ciphertext, which so far what we think logically is just plain text, whatever that is, plus k, which is the key, right? So let's say it was a. Let's say the plain text was a and a key of 1. Well, then we would want to print out b, right? We want to print the singular letter b character. So this makes sense. But there's actually a flaw with this because, let's take a look here. What if someone typed the letter Z, okay, which is very common, right? So let's say someone typed the letter Z, capital Z, and that has an ASCII value of 90, right? And let's say someone just put a key of 1, simple. So then it would convert it to whatever is the ASCII position of 91, right? Z, which is 90, plus 1, according to our formula here. So 90 plus 1 would give us 91. But what is actually in the ASCII position of 91? What is the ASCII value of 91? Well, we don't know, right? It's probably a comma or an exclamation mark or some other random character. Whereas what we don't want to print that random character. If someone prints out the letter Z and if someone inputs the letter Z and has a key of 1, we actually wanted to loop back over to A, right? So if it's a Z with a key of 2, we want it to loop back over to B, right? We want to loop back over the alphabet, essentially, rather than just printing out some random character in ASCII, going over the bounds, right? Going over bound. So what do we need to do here? Well, so we know that this doesn't work because we can't go over bound with this, right? So what we need to do is actually, and again, if you've done Scrabble, this might come a little naturally to you, and I hope you've done Scrabble. If you haven't, go back and watch that video first, do readability, and then only come to Caesar, okay? So how do we get this plain text plus key to loop back over once it goes past Z? So there are a few simple steps. So the first step is reset the values so that the alphabet starts from 0 rather than 65. Right, and this is very similar to what we did in Scrabble. So we need to send A back to position 0. Okay. And then we need to do mod 26. Okay, so for those of you that haven't come across this mod function, it's basically saying whatever the remainder is, take that as an int, and that's the value of the mod. Okay, so that mod over here, the function of it is actually to loop back, to make it a loop. Okay, so mod 26. So when it reaches over 26 characters, we want it to loop back to the beginning. Okay, we want to loop back to 0. So actually, 26 mod 26 gives us 0 because there's no remainder when you divide 26 by 26, right? Just a simple, quick explanation of what mod is. 26 mod 26 is 0 because 26 divided by 26 gives 0 remainder, whereas 28 mod 26 gives you 2 because when you divide 28 by 26, the remainder is 2. Because that's a real quick explanation of what mod is. So basically, so first we reset the values to 0, and then we do mod 26 so that it loops over, it doesn't go over bounds, right? And after that, we need to bring it back to its original ASCII value. Okay. So this might be a little bit confusing at first. Let's go straight into an example here. So this is the function we came up with. Right, minus 65 to bring it back to 0, mod 26 to loop over, and then we said we want to also plus 65 to bring it back to its original ASCII value. Okay, so why is this, right? How does this make sense? So let's say someone input the letter capital Z, okay? And capital Z, as we know, has an ASCII value of 90, right? So let's just take that as an example. Someone puts in the letter Z. So Z minus 65 would give us 90 minus 65, which is 25. And let's just say the key was 1, right? So the key was 1. So 90 plus minus 65, which is 25, plus the key, which is in this example, let's say it's 1. That'll give us 26, right? 90 minus 65, 25, plus 1, 26. Now 26 mod 26 would give us 0, right? And then we need to add back the 65 so that it prints out the letter A. So when uppercase Z is the plain text, our ciphertext would now print out whatever is in the ASCII position of 65, which is the capital A, right? Okay, so might be thinking, why do we need to add back the 65? Because otherwise, it would be 90, right, the capital Z, minus 65, which is 25, plus 1, which is 26. Now 26 mod 26 would give us 0. So it would print whatever is in the ASCII position of 0, which we don't want that. We want to print whatever is in the ASCII position of 65, which is A. So that's why we need to add back the 65. So plain text, minus 65 to set the alphabet back to 0, plus K, obviously to convert it to ciphertext. Mod 26 so that it loops back over whenever it goes over the 26. And then plus 65 to bring it back to that original ASCII value, right? So I hope that explanation makes sense. Rewind the video and watch it again if it doesn't, right? But hopefully it does make sense, right? So for J, okay, and this is only for capital letters, right? Because A is capital 65. So if it's a capital letter, and again here, we don't really want to deal with ASCII and all that again. So we know from the previous exercises that we can just write is upper for uppercase characters. So if is upper plain text J, then we want to print this, right? Okay. So hopefully everything makes sense so far. So we go to the loop, and if it's upper, then if it's an uppercase letter, then we use this formula. What happens if it's a lowercase letter? Well, we already know how to do it. If is lower, right? This is from the previous previous problem sets. Rather than saying ASCII, rather than putting the ASCII values and everything, we can simply do is lower. So if plain text is if it's a lowercase letter, what do we need to do? Well, something very similar to this, but because lowercase a doesn't start at 65, it starts at 97, right? We want to minus it by 97 to bring it back to its original position, and then add back 97 so it goes back to its original ASCII position. So it's exactly the same formula as for the uppercase. So we can just copy and paste that, right? Plain text J minus 97 plus K and bring it back to 97, right? So hopefully everything makes sense so far. If you don't understand the logic here, please rewind the video, watch it again. I'm sure you'll get it eventually. It's tough to wrap your head around because our initial instinct is just ciphertext is plain text plus key, right? But we need the mod to loop over and we need to bring it back and everything. So keep that in mind. Okay, so if it's an uppercase, then do this. If it's a lowercase letter, then do this. And so they tell us over here that we want to keep all anything that's not a letter, like let's say it's a number or a full stop, exclamation mark, whatever is punctuation, we want to leave it as it is. Okay, so let's say plain text is AB50. We want the ciphertext to be with a key of 1, let's say. We want the ciphertext to be BC50. So A plus 1 B, B plus 1 is C, but the 50 should remain as it is, right? And full stops, exclamation marks, everything should remain as it is. So we only want to manipulate the letters, okay? So over here we've done, if it's an uppercase letter, then do this. If it's a lowercase letter, then do this. Now else, if it's anything else, if it's not a letter, basically, if it's not an uppercase letter or a lowercase letter, then what do we want to print? We want to just print it as it is, right? We don't want to do anything fancy. So we just want to print the character as it is. And again, we use a placeholder C. And we just want to print it out as it is, so we don't make any changes over there. Okay. Okay, so everything here makes sense so far, right? If it's an uppercase, do this. If it's a lowercase, do this. And if it's anything else other than an uppercase or a lowercase letter, which means if it's a number or punctuation or blah, 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 print it as it is. Okay. And then after that, we just want to print a new line, right? So ciphertext, it'll print out the ciphertext as it is. And then we just want to print out a quick new line. Right? Print F. And we just want to print a new line simply there. And okay. Okay. So let's see if our code is correct. Oh. Okay, we forgot to close our for loop here. That would give us an error later on in the program. Okay. So first of all, let's compile our program, make Caesar. And a few errors here. %C, okay. So it's an error on line 33. Okay, I closed the bracket too early here. I needed to actually open a bracket here. Okay, so the error was that I didn't put the brackets, right? It's all solved now, so let's make Caesar. Okay, it compiles. Let's run /Caesar1, key of 1. Okay, it asked me for the plain text. That's a good sign. Plain text, let's say, is A. Okay, ciphertext is B. That's okay. Runs good so far. Let's say /Caesar. Okay, gives me an error. Oh, but it prompts me again on the same line, so that doesn't look very nice. So let's just put over here, start a new line when you give the error message. /n. Okay, let's make Caesar once again. /Caesar. Okay, use the Caesar key. Okay, gives me the error message. /Caesar2, let's say. A becomes C. Okay, that's a good sign. So let's just go ahead and check our code now. check 50. Okay, copy and paste it. Hopefully everything's correct, right? We've gone through this whole thing and everything seems to be correct. Hopefully it is. And by the time we're waiting for this, guys, please make sure to subscribe because we're going to be posting videos every single week. Make sure to leave a like on this video if it helped. And yeah, let's go ahead. Let's do the CS50 course together, guys. We can get through it. I know we can. Let's just go ahead and wait for our results. We've done everything correctly. Hopefully everything I've said today makes sense, by the way, guys. This one is a little bit complicated. Kind of wrap your head around the logic of the mod. If you want me to make a separate video just explaining mod so that this whole problem set becomes clear, let me know. And I'll go ahead and make a video just about that. And over here, CS50, everything is correct, guys. Okay, so thank you so much for watching. If you have any questions, leave them in the comments down below. I'll answer every single question. And that's all for today. Thanks, guys. Bye, David.